Hi everyone. Today let's talk about resistors. Resistors can be labeled as a line and a zigzag, and we label it as R. The value of the resistors is called the resistance. Typically, resistors can be connected in two different ways. One is called in series, another one is called in parallel. Now let's take a look. What does it mean when we say resistors are connected in series? Okay, let's assume that we have 1 and 2 and 3 resistors that are connected. You can keep going, adding them as the way it is now. Let's label them R1, R2, and R3. Now, the total value of the resistors when they are connected in series is calculated as R, or you can use RT, T stands for total, would be equal to simply add the values together. What about in parallel? Let's assume that we have another 3 resistors. If they are connected in parallel, which means one end of the resistors are connected together, and another end of the resistors, they are connected in parallel with each other. Okay, let's label them R1, R2, and R3. So this is an example of resistors being connected in parallel. In order to find out the total value of the entire resistance here, we are going to use the equation 1 over RT. Again, RT, T stands for total, would be equal to 1 over R1 plus 1 over R2 plus 1 over R3. If you have more resistors being connected in parallel, you can keep adding them as the way it is here. Now let's take a look at example number 1. The connection of R1 and R2, they are connected in series. So the total value of the resistance RT would be simply add the numbers together. So it will be equal to R1 plus R2 equal to 2 ohm plus 3 ohm equal to 5 ohm. The second example, again, as you can tell, the connection of R1, R2, and R3, they are in series. So based on the equation we had earlier, the total value of the resistance RT would be adding all the resistors together. So it will be 1 ohm plus 5 ohm plus 20 ohm. Add them together equal to 26 ohm. Now let's take a look at the example number 3. Again, by looking at the connection, it is pretty straightforward that they are connected R1, R2, R3, R4, R5 in series. So the total value would be based on the principle by adding all the numbers together. Now let's do the substitution. R1 equal to 5 ohm, R2 1 ohm, R3 5 ohm, R4 1 ohm, R5 5 ohm again. Now add the numbers together equal to what? 17 ohm. So that will be our final answer. Okay, based on the examples here, what is the pattern do you see? If we compare the value of the R total with each individual resistors, we realize that the R total is always greater than any of the individual resistors. Same here, the second example, our total is 26 ohm. It is larger than any of the individual resistor. And the very last example, 17 ohm total, it is bigger than each individual resistor. So the conclusion is when resistors, they are connected in series, the R total will be always greater than any of the individual resistors. Now let's take a look at resistors in parallel. First example, we have 2 resistors, R1 and R2. They are connected in parallel with each other, head by head connected and by end connected. So in this case, we're going to use the equation here for resistors in parallel. I'm going to copy down the equation. 1 over R total is going to be 1 over R1 plus 1 over R2. So R1 is 2 ohm and R2 is 3 ohm by doing the substitution. So now let's just look at the numbers. So forget about the units for a little bit. So we have 1 over R total equal to 1 over 2 plus 1 over 3. Those two numbers add together, we need to find what is the common denominator. So it's going to be 6, right? So we'll have a 6 here, and at the top is going to be 3. So 3 over 6 is equivalent with 1 over 2. And the second number is going to be 6 here, so top will be 2. So 2 over 6, if we cancel out the common factor, it is equivalent with 1 over 3. So now denominator is same, 6, and we can add the numerator together, 5. 1 over R total equal to 5 over 6. In order to find the value for RT, we can flip it over so that way we can find the value of RT. So after we flip over everything, left is going to be RT. Right is going to be 6 over 5 after we flipped it over. So now 6 divided by 5 literally equal to 1.2. And don't forget the units ohm. So which means the final answer for the total resistance is equal to 1.2 ohm. Second example, we have two resistors. They are connected in parallel with each other. So head by head connected, end by end connected. And both of them equal to 5 ohm. In this case, again, let's copy the equation first. 1 over R total is equal to, now let's plug the numbers in. R1 equal to 5 ohm, R2 also equal to 5 ohm. Now let's do the calculation. Forget about the units for a little bit. So 1 over R total is equal to 1 over 5 plus 1 over 5. Now look at here, we have the same denominator, which means we can add the numerator together. So 1 plus 1 here equal to 2. Now the next step, we're going to flip over both sides at the same time, which means R total, after we flip it over, we also flip it over here at the same time, would be equal to 5 divided by 2. So the value of the R total is going to be 2.5. Again, don't forget about the units ohm. So the final value for R total equal to 2.5 ohm. If you take a look at the result here, 2.5 literally is half of the 5 ohm. If two resistors, they are connected with each other in parallel, if their value is identical, the total resistance is going to be the individual resistors divided by how many resistors are being connected with each other in parallel. In this case, each individual of the resistor is 5 ohm, and we have 2 of them connected with each other. That's why the final value is going to be 2.5 ohm, which is exactly the value we get based on our calculation. Now let's take a look at the third example. Right now, if you look at the value of the resistance, each of them are 6 ohm, 6 ohm, and 6 ohm, and they are connected in parallel. Based on the pattern we mentioned earlier, we can assume that the total value RT is going to be each individual value of the resistor divided by how many of them are connected in parallel with each other. So in this case, we have a 1 and 2 and 3 of them. So we are going to divide by 3. Now we do the calculation, we find out equal to 2 ohm, but we don't know whether this is correct. Let's do the calculation to find out. Okay, so 3 resistors connected in parallel based on the equation. We have a 1 over R total equal to 1 over R1 plus 1 over R2 plus 1 over R3. Do the substitution. R1 equal to 6 ohm, R2 6 ohm, R3 also 6 ohm. And let's do the calculation by forget about the units for a little bit. So 1 over RT equal to 1 over 6 plus 1 over 6 plus another 1 over 6. And we have the same denominator 6 here. So we can keep the denominator and add the numerator together equal to 3. We cancel out the common factor, divide by 3, both on the top and the bottom. So we get 1 over 2. 1 over RT equal to 1/2. So next step we can do is flip over both sides at the same time. So this left flip over equal to RT. Right side flip over equal to 2. And don't forget of the units. So the final answer is going to be 2 ohm. Now let's compare this 2 ohm with the initial assumptions we received based on the pattern. They actually match with each other. It's telling us that if we have multiple resistors connected in parallel, if all the resistors they are identical in value, then the total value is going to be the value of the individual resistors divided by the number of the resistors you have in the connection. What if we have 4 resistors connect with each other and all of them are identical and each value is 8 ohm? So what should be the total resistance here? Based on our observation, we know that in this case, they are connected in parallel and they are identical. So the total value is going to be equal to the individual resistors divided by the number of the resistors that you have. So 1, 2, 3, 4, and we will find out the total value will be equal to 2 ohm. Another example, let's assume that we have 3 of them get connected with each other, and each of them is 15 ohm in parallel with each other. So what should be the total value here? Again, because they are all identical and they are connected in parallel, so the total is going to be the value of individual resistance divided by the number of them. So in this case, we have 1 and 2 and 3 of them. So divided by 3. And the final answer will be equal to 5 ohm. Okay, so these are just some of the tricks that I would like to share with you. Now, let's take a look at the value of the total resistance for the parallel connection. What do you find? Let's look at the first one. The first example, the total value is 1.2 ohm. If you look at each individual resistors, it's 2 and 3 ohm, which means the total value actually is smaller than individual resistors being connected. The second example, the total value was 2.5 ohm. Compare with each individual resistor, so 5 ohm, it is also smaller than individual resistors being connected. Next example, the total value was 2 ohm. It is also smaller than each individual resistors being connected. From all those examples, we can find out the total value of the resistance will be always smaller than each individual resistance if it is connected in parallel. Again, as a conclusion, if all the resistors are connected in series, then the total value must be bigger than any of the individual resistors. However, if the resistors they are connected in parallel, then the total must be smaller than each individual of them. Additionally, if resistors they are connected in parallel and they are identical in value, then the total must be equal to each individual resistor divided by the number of the resistors that you have in connection. And this only applies to the situation where the resistors are connected in parallel. And we had some examples earlier to demo that. Okay, so those are the basics of the resistors. I hope it's helpful. Let me know if you have questions. Have a wonderful day.